we are learning to use our place value to solve multiplication problems. Here's an example of a problem. There are 5 tables in the classroom. Each table has 6 chairs around it. How many chairs are there altogether? If I was going to draw that problem out, then I would draw 5 tables. 1, 2, 3, 4, 5. And I'm going to put a 6 in the middle of each table so that I know that that's 6 chairs in each table. So I know that this problem is asking me for 5 groups of 6. Now, I need to stop adding to figure this out, because I could skip counting 5s to figure that answer out, going 5, 10, 15 and so on, but I need to start using my times tables now. You're going to get a printout that looks like this. I can use one of these grids to help me figure out the answer to times tables while I'm still learning my times tables, so I don't have to go back to counting all the time. So what you do is you find the 2 numbers that are in your times table. So mine was 5 groups of 6. So on this side I find 5, and up here I find 6. 5 groups of 6. Then all I need to do is figure out where they meet. So they meet here at 30. If I go across from 5 and down from 6, then they meet at 30. So 5 times 6 is 30. Remember the other day how we talked about the commutative property, where you can change the order of your times table numbers and it still equals the same thing? If I went 6 here and 5 here, and I went across from my 6 and down from my 5, you can see that actually they both end at 30. They give you the same answer. So it doesn't matter if you get the order of the numbers around the wrong way. You just need to find one of each on each side and go down to solve the problem. So if I went back to the problem that we had before, here I'd know from using my times tables chart that 5 times 6 is 30, so that there would be 30 chairs. I didn't need to count this time, and I didn't need to add, because I just used my times tables chart to help me when I didn't know the times table. I can use that while I'm practicing until I've memorised all of my times tables. We can use our times tables charts to help us even when the numbers in the problem are bigger than the chart, like this one here. Children were split into groups at camp. There were 13 groups and 4 children in each. How many children were at the camp? I can see here that we've got the numbers 13 and 4, and I know from my grouping that that means that the question is 13 groups of 4. Now, my times tables chart only goes to 12. That's the biggest that they have, so I might think that I can't solve this problem using my chart, but I can use my place value to break up this number. The first thing I can do is figure out what 10 groups of 4 is. I can see that if I find 10 and 4 and figure out where they meet, the answer to that is 40. So 10 times 4 equals 40. So I've done my 10. Now if I work out 3 times 4 using my chart, I can go find 3 and 4, and my 4's already highlighted, so I just figure out where they meet, which is 12. So 3 times 4 equals 12. All I need to do now is add these 2 numbers together, and I have the answer. Here's the last question that I'm going to show you. There are 15 stacks of books on the table. In each stack, there are 3 books. How many books are there all together? So for the last time, I'm going to use my times tables chart, and I'm going to break my bigger number here, 15, up into 10, and 5 groups of 3 because I can't figure them all out on the one chart. So first I'm going to go 10 times 3 equals, and find that here, 10 times 3 is 30, and my next move is going to be 5 times 3, so I've got 5 and 3 there, and that's 15. So 10 times 3 is 30, 5 times 3, I can see here, is 15, and 30 and 15 are 45. So my answer to 15 times 3 is 45.